Hi friends, welcome back to our YouTube channel. Today we have to discuss about Q in data structures course and advanced data structures course. First of all, what is data structure? A data structure is a way of storing and organizing the data in an efficient manner. Data structures are classified into two ways. First one is linear data structure. Second one is non-linear data structure. In the case of non-linear data structure, data can be stored in the form of a hierarchical manner, that is tree structure. The examples for non-linear data structures are trees and graphs. Whereas in the case of linear data structure, data can be stored in the form of a linear fashion or a sequential fashion. The examples for linear data structures are stack, queue, linked list, array. Now we can go for queue data structure. A queue is a linear data structure. A queue is a homogeneous collection of elements in which insertion can be done at one end, deletion can be done at another end. Insertion can be done at rear end, deletion can be done at front end. So this is the diagrammatic representation of stack. Insertion can be done at this end. This end can be called as a rear end. Deletion can be done at this end. This end can be called as front end. So insertion can be done at the rear end. Deletion can be done at front end. Okay. So a queue is a linear data structure in which insertion can be done at this end. Deletion can be done at this end. Insertion can be done at the rear end. Deletion can be done at front end. So here insertion operation is also called as NQ operation. Deletion operation can also be called as DQ operation. So NQ operation is used for inserting an element at rear end. DQ operation is nothing but deleting an element from the queue at front end. Next, queue works on a principle called first in, first out. That means queue works on a principle called FIFO, F-I-F-O. F-I-F-O stands for first in, first out. That means whatever the element which is inserted first into the queue, that element can be deleted first. For example, I am inserting elements 10, 20, 30, 40, 50. First we are inserting element 10 at rear end. We are inserting element 10 at rear end. Next we are inserting element 20. At that time 10 here, 20 here. Next we are inserting element 30. So here 10, here 20, here 30. Next we are inserting element 40. Next, we are inserting element 50. Now, among these 5 elements, which element is inserted first into the queue? That is 10. So that element can be deleted first. Whatever the element which is inserted first into the queue, that element can be deleted first. Here, which element is inserted into the queue first? 10. Whenever we are performing delete operation, that element can be deleted first. That is, 10 can be deleted first. This principle can be called as FIFO, first in, first out. That means whatever the element which is inserted first into the queue, that is element 10, that element can be deleted first. So element 10 can be deleted first. Next, what are the operations that can be performed on the queue? So first one is NQ operation, second one is DQ operation, third one is display operation, fourth one is full operation, fifth one is empty operation. So NQ operation is used for inserting elements into the queue at rear end. DQ operation is used for deleting elements from the queue at front end. So insertion can be done at the rear end, deletion can be done at front end. Next, display operation is used for displaying all the elements in the queue. Next, is full operation. Is full operation is used for checking whether the queue is full or not. Is empty operation is used for checking whether the stack is empty or not. So is empty operation is used for checking whether the queue is empty or not. Okay. Is full is nothing but queue is full with, or a queue is full. Queue contains all the elements. Suppose queue size is 5 starting with 0 and ending with 4. So 5 elements are possible to insert into the queue. At that time, 5 elements are inserted into the queue. We can say that is full, queue is full. Suppose 5 elements are deleted from the queue. At that time, queue is empty. So, is empty operation is used for checking whether the queue is empty or not. Is full operation is used for checking whether the queue is full or not. Next one, queue can be implemented in 2 ways. First one is queue can be implemented using arrays. Second one is queue can be implemented using linked list. Next, what are the real life examples of queue? First one is movie counter. When we are going to the movie, so we have to take the tickets. At that time, we have to follow a queue. At that time, we have to follow queue. That means whatever the persons that we want to take the tickets, that persons are arranged in a sequential fashion. That is nothing but queue. Next one, process scheduling. Suppose we are taking one CPU. On that CPU that we want to execute 5 processes P1, P2, P3, P4, P5. Okay, at a time, one process is executed on the CPU. Okay, at that time, these 5 processes are stored in a queue. Okay, so that is called as process scheduling. Next, third one is a reservation counter. Suppose we want to take a reservation, either a bus reservation or a railway reservation. So when at that time we are going to the bus station or a railway station, so many persons are waiting for taking the reservation. At that time they are standing in the form of a queue before the reservation counter at the bus station or at the railway station. So these are the real life examples of queue data structure. Next, types of queues. There are 4 types of queues. First one is a linear queue. Second one is circular queue. Third one is double-ended queue. And fourth one is priority queue. Linear queue is nothing but whatever we have learned up to that point, that becomes the linear queue. Second one is circular queue. In the case of circular queue, the elements are stored in the form of a circular fashion. Next one is double-ended queue. In the double-ended queue, both insertion and deletion operation at both ends. Insertion and deletion operation can one end, and also deletion and insertion operation can be done at other end. That means both insertion and deletion operations can be done at both ends. Hence we can say that that type of queue can be called as double-ended queue. Next one is priority queue. So here we have to assign the priorities for the processes. Whatever the process that has the highest priority, that process can be executed first. Whatever the process that has low priority, that process can be executed at the last. Okay. Suppose there are 5 processes are there: P1, P2, P3, P4, P5. P1 priority is 5, P2 priority is 10, P3 priority is 6, P4 priority is 8, and P5 priority is 2. Okay, which process is executed first? So the process that has the highest priority, that process can be executed first. P2 process has the highest priority 10, so that it can be executed first. After that, next highest priority which process has, that can be executed next. Which process has the lowest priority, that can be executed last. Okay. Next one is queue overflow. So what is queue overflow? Suppose queue size is 5. Queue contains 5 elements. At that time, queue is full. Suppose we want to insert another element into the queue. So it is not possible to insert that element. That situation is called as queue overflow condition. Trying to perform enqueue operation or a insertion operation, if the queue is already full, then that condition can be called as queue overflow condition. What is the syntax for queue overflow condition? So rar equal to size minus 1, where size is nothing but size of the queue. Okay. For example, Here queue size is 5. That means it can store only 5 elements. Suppose we want to insert element 10 into the queue. So it is inserted at the rear end. So 10 is completed. Next, we want to insert element 20 into the queue. So now rear pointer pointing to this one, rear pointer. Next, we want to insert 30 is into the queue at that time. So here 10, here 20, here 30. So at that time, rear pointer pointing to this one. Next, we are inserting element 40 into the queue. So at that time, so 10 goes here, 20 goes here, 30 goes here, and 40 goes here. So pair pointer pointing to this one. Next, we want to insert element 50 into the queue. So at that time, 10 goes here, 20 goes here, 30 goes here, 40 goes here, and 50 goes here. So rear pointer pointing to this one. Okay, so queue size is 5, queue contains 5 elements. At that time, we can say that queue is full. Suppose we want to insert element 60. It is not possible to insert 60 into the queue because queue is already full. That means queue contains 5 elements. Okay, so at that time queue overflow condition is occurred. So rear equal to size minus 1. Okay, rear pointer pointing to this one. So queue size is 5. So size minus 1. Size minus 1 means 5 minus 1. That is 4. Rear equal to 4. So here this is the rear end pointing to 4. Then this situation can be called as a queue overflow condition. Trying to perform enqueue operation or insert operation when the queue is already full. That situation is called as queue overflow condition. So the code for representing queue overflow condition is equal to rear equal to size minus 1. So initially rear pointing to minus 1, we are inserting first element 10 into the queue, rear pointing to 0. Next we are inserting element 20, rear pointing to 1. Next we are inserting element 30, rear pointing to 2. Next we are inserting element 40, rear pointing to 3. Next we are inserting element 50, rear pointing to 4. So queue size is 5, rear equal to 5 minus 1, that is 4. Rear equal to 4, then we can say that queue is overflow condition. Next one, queue underflow condition. So trying to perform delete operation or dequeue operation when the queue is empty. Okay, for example, so rear pointing to this one also. Suppose we want to perform delete operation or a dequeue operation. So first, which element is deleted? 10 is deleted. At that time, so rear pointing to this one and front pointing to this one. Whenever delete operation is performed, front is incremented. Whenever NQ operation is performed, rear is incremented. Next, we want to perform one more element from the queue. So at that time 20 is deleted. So now the front pointing to this one. Front pointer is incremented. Now front pointing to 30. Again we have to perform one more delete operation. Now 30 is deleted. So front pointing to 40. Again we have to perform delete operation. So now 40 is deleted. Again we have to perform delete operation. 50 is deleted. Okay. So now all the elements are deleted from the queue. So at that time queue is empty. Again we have to perform delete operation. So in that situation queue is underflow condition. So what is the code for representing queue underflow condition? Front greater than rear. Front greater than rear. Okay, this is the condition for representing queue underflow condition. What is the condition for representing queue overflow? Rear equal to size minus 1. What is the representing queue underflow condition? So front greater than rear. So now we can go for 3 important points. The first point is initially both front and rear pointers pointing to -1. So front equal to rear equal to -1. So that is nothing but Q is empty. Whenever front pointer pointing to -1, rear pointer pointing to -1. At that time we can say that Q is empty. Note point 2. Whenever the first element is inserted into the queue, at that time both the front and the rear pointers are incremented. So front pointer incremented from -1 to 0, rear pointer incremented from -1 to 0. So that means front equal to rear equal to 0. That means Q contains only one element. Okay, front equal to rear equal to -1 is nothing but Q is empty. Front equal to rear equal to 0 means Q contains single element. After that, whenever NQ operation is performed, rear pointer only incremented. Whenever DQ operation is performed, front pointer is incremented. Okay, so first element insertion, at that time both the front and rear pointers are incremented from -1 to 0. After that, whenever insert operation is performed, rear pointer is incremented. Whenever delete operation is performed, front pointer is incremented. So these are the 3 important points. Keep in mind while implementing the queue operations. Perform the following operations on the queue of size 5. That means queue size is equal to 5. The indexes starting from 0 to 4. So these are the indexes starting from 0 to 4. Initially, rear pointer are equal to -1 and front pointer pointing to -1. So rear pointer can be denoted by R, front pointer can be denoted by F. Whenever R value equal to -1 and F value equal to -1, we can say that Q is empty. First, we have to perform NQ of 10. Now, we are inserting element 10 into the queue. At that time, both front and rear pointers are incremented. So now rear equal to 0, front equal to 0. Whenever the queue is empty, both the rear and front pointers are pointing to -1. First, we are performing NQ operation. At that time, both the front and rear pointers are incremented from -1 to 0. After that, whenever NQ operation is performed, so rear pointer R is incremented. Whenever DQ operation is performed, front pointer F is incremented. Next we are inserting NQ of 20. So we are inserting element 20 into the queue at that time. So rear pointer incremented to 1. Next we are inserting element 30. So now we are inserting element 30 into the queue. At that time, rear pointer is incremented from 1 to 2. Next, we have to perform DQ operation of 10. So now 10 is deleted from the queue. At that time, front pointer is incremented. So now F is equal to 1. Next, we are inserting element 50 into the queue. So element 50 is inserted into the queue. Hence, rear pointer is incremented from 2 to 3. Next, we have to perform DQ of 20. So now we are deleting 20 from the queue. Then front pointer is incremented from 1 to 2. Next, we have to perform NQ of 60. Now we are inserting element 60 into the queue so that rear pointer is incremented from 3 to 4. Next, we have to perform DQ of 30. Now we are deleting 30 from the queue so that front pointer is incremented from 2 to 3. Next, we are inserting element 80 into the queue. So it is not possible to insert 80 into the queue because rear pointer pointing to size -1. Size -1 is nothing but size value 5 minus 1, that is equal to 4. Whenever rear pointer are pointing to index 4, it is not possible to insert element into the queue even though 3 empty slots are available. That situation is called as queue overflow condition. Queue overflow condition. What is queue overflow condition? Whenever the rear pointer pointing to size -1, so that is 5 minus 1, that is equal to 4. Whenever the rear pointer pointing to 4, at that time it is not possible to insert element 80 into the queue. That situation is called as queue overflow condition. Next operation is DQ of 50. DQ of 50. Next, we are deleting 50 from the queue. Then front pointer is incremented from 3 to 4. Next, we have to perform DQ of 60. So we are deleting 60 from the queue. At that time, front pointer pointing to 5. Front pointer is incremented from 4 to 5. Okay, so whenever in this situation Q, again we have to perform DQ operation. Again we have to perform DQ operation. Again we have to perform DQ operation. In that case, we can say that Q is already empty. At that time, we have to perform DQ operation. In that case, we are getting Q underflow condition. Q underflow condition. What is the condition for Q underflow? Front greater than rear. Front greater than rear. So front value is 5 and rear value is 4. So 5 greater than 4. So this situation is called as Q underflow condition. Q is already empty. Again we have to perform DQ operation. So then Q underflow condition is occurred. Okay. Again we have to perform NQ operation. Again we have to perform NQ operation of N. Here the Q is already empty. There are no elements are there, but it is not possible to insert element 100 into the Q because rear pointer pointing to 4. At that time we are getting Q overflow condition. Even though empty slots are available, it is not possible to insert element 100 into the Q because rear pointer pointing to size minus 1. Okay, so this is the disadvantage of Q. Okay, Q is empty, but it is not possible to insert a new element into the Q whenever rear pointer pointing to size minus 1, that is equal to 4. This is the main disadvantage of Q. To overcome that disadvantage, we have to use circular Q. Whatever the disadvantage that is occurred in the Q, to overcome that disadvantage, we have to use another data structure called as circular Q. That can be discussed in the next videos. Okay, I hope all of you understanding this video. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. In the next video, we have to elaborate the Q operations, NQ operation with code, DQ operation with code, display operation with code. That can be discussed in the next video. If you really understanding this video, please subscribe my YouTube channel, Divvela Srinivasa. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Thank you one and all for watching this video.